I didn't either.
She never
We
said.
did that like last week.
Yeah.
I'm like,
Okay, everybody ready?
yes, it's in the function.
Yes, functions. Let's put the fun in functions.
Alright.
Okay.
Fun, yay.
Do you like beavers?
Ah, well, I mean, I got that on the Facebook free site. Who could turn that down? It's a beaver pencil sharpener. Isn't that cute? Isn't it funny?
I like that.
And then it's a sea otter.
Does it work?
Yeah, okay.
Sharpen your pencil.
Oh.
Yeah.
Guys, anyone have
What?
Yeah.
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 To finish the package.
But like not be fancy.
Okay, so we are calling this one 1-4. I'm gonna call this. I'm gonna call it what I called the worksheet, but I'm gonna add some more to it. I don't know. Evaluating functions. And operations. That's what I'm going with. Oh. Evaluating functions and operations. So before we get into evaluating functions, we need to figure out what in the world they even are. Okay, so I heard a couple of thoughts out there. So functions, what even are they? So these are relationships between two sets of numbers. Okay, so we'll start off with that. Relationship between two sets of numbers called the input or X values and the output, which is the Y values. There's more to it though. So just having the relationship, we call that a relation. You have these two sets of numbers that have something to do with each other. Now, if it just so happens where every input that I put in only gives me one output, that's what makes a function a function. So in other words, here's a real world example of a function. If I asked you how old you are, you have one answer. We're talking years, right? So you would say, I'm 15, I'm 16. You can't be two ages at once. You're not 15 and 35 at the same time, right? You might feel like you are, but you're not, right? So if you ask someone their age, there's one answer that comes back out. Okay, so there's the idea of a function. Now, could multiple people be the same age at the same time? Of course they can. So that doesn't matter, but you are only going to be one age at one specific moment in time. Does that make sense? Okay, so if I asked you what your age was and you literally had two different answers, now it's not a function anymore. Because now, okay, well, which answer am I giving? Who knows? All right, so relationship between two sets of numbers called the input and output, where for every input, there is exactly one output. So there's the basic idea. That's what functions are. You deal with them all the time in math. You don't even always realize that you're dealing with them, but you are. Okay, let me show you some different ways we can display these relations, and then we can tell if they're functions or not. So let's start off with one of the easiest ways is something called mapping. So what we can do is I can say, hey, in this bubble, I'm gonna list all my X values. And in this bubble, I'm gonna list all my Y values. I'm sorry. So I'm just gonna make them up. It doesn't even matter what they are. Let's say it's 1, -3, and 0. And in the Y's, let's go 2, -1, -5. Who cares? So these in my X bubble are all my inputs. So if I put in +1, if I want to show you what I get out as a Y, I just draw an arrow. So let's pretend that when you plug in a 1, it spits out a -1. If you plug in a -3, let's pretend it spits out a +2. And let's pretend that if you plug in a 0, it spits out a -5. In this example, we do have a function because none of my X values are giving me more than one answer. They are all, when I plug in 1, I'm only getting one answer back out. When I plug in -3, I'm only getting one answer back out. So this would represent a function. Let me show you an example that is not. And then I'll give you one where you guess. So here's an X, here's a Y. Again, it doesn't matter what the numbers are. Let's say I have 1 and 7, and over here, 0, -2, and 4. Could be anything, who cares? Let's say when I plug in 1, I get out 0, but when I plug in 7, I get out -2, and I get out 4. Now I have a problem. Because when I have plugged in one of my inputs, I got 2 outputs. And that can't happen in a function. So this, not a function. Let me give you one more. And I want you to give it a guess what you think if it is or isn't. So here's some X's, here's some Y's. What if I did 1, 3? I don't know why I can do 1s. Who cares? It could be anything. I'm gonna add another.
Please pardon the interruption. At this time, all academic freshmen, please report to the auditorium. All academic freshmen, please report to the auditorium. Thank you.
Oh, I didn't even realize that I forgot some of your questions. Well, enjoy your celebration.
What's it on? You didn't get one
No,
of
what?
those.
Well, you were also freshmen and like.
We don't know that.
We partied up on there.
Look to Jupiter if you could later. All right, enjoy.
Yeah, Jill, yeah.
We all just show up. I think they'll notice.
Yeah.
All right, thoughts on this last one? Would you think that this is a function or is not? You're correct.
Good job. That's it. Kind of cool.
So the reason why this one is because remember, the only thing I'm checking for, everything in my X bubble can only go to one thing in the Y bubble. So each of these only has one arrow coming off of them. It does not matter that these two are both going to the same number. That doesn't matter. Right? Just like if I ask people how old they are, there's going to be tons of people that are the same age, but you yourself are only ever one age at a time. It's the same idea. So these two just happen to have the same Y value. We don't care about that. All I care about is that the X coordinates can't go to more than one spot, and they're not in this case. So that is a function. All right. So that's one way to, that's one form that you might see functions and relations drawn in. That's called mapping. Sometimes we also just give you them as coordinates. And that's, I think it's a little bit easier. I don't know, they're all pretty easy. So I could just list coordinates for you. So like, I don't know, 1, 2, 4, -9, 3, 6. So again, what I'm checking for, this is the same thing as mapping, just drawn as coordinates. So instead of me just drawing an arrow, I'm just writing the two of them together. So then I'm looking at all of my X values. I don't really care what the Y values are, to be honest. I'm looking at the X's. I have 1, 4, and 3, and they're all only going to one Y value. So that, if my X's never repeat, that is a function, because that's showing me that every X value is only going to one Y value. So yes, a function, because X's never repeat. So if you saw this, see how we have a problem? What's the problem? Exactly. If I plug in 3, it's giving me out 2 different Y values. In one scenario, I get a -4. In one scenario, I get a 7. I can't have that. When I plug in a number for X, I can only get one number back out for Y, and I'm not here. So this is not a function, because X is repeated. So let me give you one, and you guess, is it or isn't it? What would you say for this one? Is it a yes? Is it a no? I'm hearing mostly yeses, it's a function. Yes. Well, I agree with you. Well, that's good news. But how? There's so many -2s in here. What do you mean? It doesn't matter if both of these numbers are the same. We don't care about that, right? That doesn't matter. All I care about is literally, I don't even look at the Y's. The Y's don't matter. I'm looking at the X's. -2, 4, and 5. The X's never repeat, so it's automatically a function. My X's didn't repeat. I don't care what the Y values are. Everybody could have the same Y value. It's the X values that matter. So this is a yes. X's don't repeat. Oh, D goes this way, so it goes. Okay, and then the last pretty common way to look at relations to tell if they are functions or not is to actually look at a graph. And that is where you may recall something called the vertical line test. I have to flip the page. Do you know what the vertical line test is? Do you remember doing it at some point? Let me, raise your hand if you've never heard of the vertical line test. You have no idea what I'm talking about. It's okay if you don't. I'm gonna teach it to you. Everybody knows? Well, all right then. So if I have a graph of something, so let's just say, use a different color. Let's say my graph looks like something like that. Who cares? The vertical line test is a way for us to tell if this thing is a function or not just by glancing at it. And here's what you do if you're not aware. You are going to visualize a vertical line passing along through your line. And if it ever hits more than once, then it has failed the vertical line test. This one passes. So if I move my ruler along, so if you're looking at my curve here, it never hits more than once. So that means that that is in fact a function. Okay, a vertical line through the curve never hits more than once, so that's how I know so it passed the vertical line test. So I'll just add that, passed vertical line test. So that's what it means to pass, is that it never hits more than once, so I do have a function. So of course, I want to give you an example of one that fails. You could do so many things. You could do a circle, you could do a roller coaster loop-de-loop. I'll do that. Loop-de-loop. It doesn't matter where on the curve it fails. If it fails anywhere, it is not a function. So as you can see, when I pass my vertical line, very quickly I hit places where it hits more than once, so you have failed. Not a function. Failed. Vertical line test. And let me give you one to try. What would you say about I know. Have you ever seen a graph like this before? Have you seen one like that? What do you think about that? Does that pass or does that fail, Jimmy? It is a type of parent function that is 1 over x. If you were going to graph 1 over x, that's what you would get out. So Nathan, what do you think? It does pass the vertical line test. It's helpful to have a little bit of knowledge about this graph and what is happening. Each of these branches is getting closer and closer and closer to the x and y axis, but it never actually touches it. So it just gets incredibly close to it. So yeah, this actually does pass the vertical line test. That's probably the trickiest kind, something like that. Yes, passes vertical line test. Oh, you know what? This is actually 1 over negative x, because I think I have it. Normally they're in the other branches, but you get the same idea. Okay. Let's talk about function notation. So now that if we have established we're dealing with a function, function notation. Notation. Let's just take a straight line, like y equals 2x plus 5. This is written in what we normally call XY notation, I guess, because we're using X's and Y's. So I'll call this XY notation. When I rewrite this in function notation, let me show you what it looks like and let me tell you what the pieces are. It's the same exact line, okay? I'm not changing anything, but I'm going to write it in function notation. It's going to look like this. f of x is how we say that, 2x plus 5. Have you seen this notation before? Oh, good. If you haven't, that's okay. I'm going to explain it to you. This f doesn't have to be an f. It could actually be any letter. It could be a G. It could be an H. It could be an M. It could be a J. It could be anything. Why is it an F? Because the function starts with F, literally. So we usually just pick F for function because we're not that fancy. Oh, fancy starts with F too. But it could be any letter. This is literally just what I'm naming this line. I'm giving this line a name just for a minute so I can refer to it. What if I have, 6 different lines on the same graph? It's really hard to distinguish between them if they're all in XY notation. But if I'm using function notation, I'm saying, hey, I'm calling this one F, this one G, this one H. It's very easy to distinguish between my different functions if I have more than one of them. Does that make sense? I can just say, hey, look at the F function. Look at the L function. And you know exactly which one I'm talking about very quickly. If they were all like this, I couldn't just say, hey, look at the Y function because they're all Y's. You know what I mean? So that first letter is literally just the, it's a way for me to name the function. And it can be any letter. I mean, obviously we avoid certain letters like O, just because you're gonna think it's a 0. The one that bothers me the most is V and U.
Oh, that's true.
When they put them in the same one, especially, I'm like, come on, who knows what these are?
They're, like, close together.
Ah, yeah. All right, and then we have, this does not mean F times X, which is one thing that I love math, okay? Let me just put that on the record. Love math, do it all day long, every day for as long as I can remember, right? Some things I hate about math. I hate that we use the same notation for completely different things, right? Because that could mean F times X. But now when we're in function notation, we're saying, haha, forget everything you learned about that. We're pretending that it means something else now. I wish that there was just a different symbol that we use, but there's not. Okay, so that drives me crazy, but what can I do? I guess I could start a change.org petition, but it's not going to go anywhere. I'll tell you that much. So anyway, this, like I said, does not mean F times X anymore. We say it out loud as F of X, which is kind of weird. But this whole chunk, so if you're going to say it out loud, we're going to say it as F of X. And all it really means is, hey, whatever is inside that parenthesis, in this case, it's just an X, that's my input. That's what I'm going to put into this. And on my right-hand side is just whatever the function is. So I can replace that X with numbers or other variables. So if I wanted to find F of 7, let's say, that just means, hey, take the 7 and plug it in on the right-hand side of the equation and then just evaluate it. So let's see what that looks like. So now you can, if I come down here, if I just say find F of 7, so it would look like that. All it literally means for you to do is take 7 and plug it into the right-hand side of the equation. So that's now going to look like 2 times 7 plus 5. I don't really do anything on the left-hand side. I'm not solving for F. F is not a variable here. So it's just saying, hey, the value of my function that I called F at 7 is, I'm only going to do the work on the right-hand side. So that's 14 plus 5. So I get F of 7 happens to have a value of 19. So this means that the F function, when my input is 7, or my X value is 7, the output or Y value is going to be 19. That's what's going on here. Does that make sense? F is not a variable. It's just the name of this thing. So it takes a little getting used to, especially if you've never seen this before, but it's so nice because now I could literally write a whole problem by saying, all right, now do f of -3. Go ahead. So you're just going to jump back to your f function. The original function never changes. Once I have said, hey, this is my f function, I can go back to that same f function as much as I want. So go back to that f function, take that 2x plus 5, and now just pop in that -3. Okay, you got it? Who's got my answer? What is f of -3? Go ahead, Sam.
11. Oh, God. Oh, what?
It's a negative.
Oh, it's a -3. Oh, my God. I'm so dumb.
You are not.
She's gonna see you are.
No, I would never.
Sam, you're so
Is it
smart.
-1?
Yes, -1.
Okay, so where you got it.
At least she got that. She got that.
Maddie, I pulled a Maddie.
All right, so did we all land at -1 now?
No,
Does that make sense? Okay, great. So let me just give you a couple more examples where we have more than one function. Okay, so now I'm going to sneak in over here, trying to conserve my sheets. Let's say that the f function, let's say f of x is x squared. Let's have g of x. So now I'm just introducing another one. I'm like, hey, I'm just going to call this one g because I already have this one over here that's f. Let me call this one a different name so we can distinguish between the two easily. Let's make this one, how about -x minus 4? And you know what? Just for funsies, let's throw in an h of x. Oh, how about square root of x? That'll be fun. Okay, so try and find the following. Let's say f of -3. Let's find h of 36, I don't know. And let's find g of -2. Okay, find for me those three. So the first letter just tells you which function you're looking at. In this case, you'd go to the f, and then you just pop in the -3. The next one, that's h of 36, you know, oh, I'm using the h function for this. There is one of these, I fear. Oh, no, you probably get it right. Oh, I should have tricked you another way. I haven't thought. Maybe I'll do one more example. Okay, we got answers? Who thinks they have number 1, f of -3? Lizzie? +9? I agree with you. So what I'm going to do, it's starting with an f, so I know I'm dealing with this one. I'm going to take -3 and I replace it for x. Now listen, I hope you wrote it down. Think of what this means. This means take whatever x is and square it, right? So I'm going to take whatever number I'm plugging in and I'm going to multiply it by itself. That's what squaring means, right? So if it was 5 squared, I'm doing 5 times 5. Just because my number is negative, I'm still going to take my number and I'm going to multiply it by itself. So I'm really going to do -3 times -3. look at your papers. I wonder how many of you wrote it like this. Did you write this and say that that was positive 9? If you did, you got this answer right, but that writing it like that is totally wrong. If you want to square a negative number, what do you have to do? It has to be in parentheses. You can't square a negative number without parentheses. I know you do it in your brain, but if you're writing it on paper, there's a big difference. So you should have put that in parentheses because it's a negative number and you're going to square it. So just a side note, I know you probably got positive 9 as the right answer because you knew in your brain what you were supposed to do, but on paper, they're totally different things. And hoosers. Number 2, of course, is just going to be 6 because I'm doing this. Oh, I should have done the square root first. Just to make sure that it's clear where we're getting that from. So I'm going to the h function, which is the square root of x. Square root of 36 is just 6. Okay, cool. And then g of negative 2. Negative 2, you say. I agree. I'm going to take that negative 2 and plug it in. Now look, in my original, there's a negative sign. That's still there. And then I have to put in a negative 2 in place of that x. So what it looks like is negative 2 minus 4. And what happens when you have minus a negative? Or a double negative like this? Becomes a plus. So you really have, that becomes plus the positive. So 2 minus 4 is in fact negative 2 is my final answer. How did you do? Good? I'm so glad. So now I'm a little torn. I have a smidge more to talk about. I mean, we've got 20 minutes. Yeah, it's easy. So let me just get through this one little part and then you guys can get your homework done. Okay, so operations real fast. Operations with functions. Oh, you know what though? Because, you know, I'm looking at your homework and there's some trickier examples of what goes in there. And it's Nathan's birthday.
Oh, yeah, we really do. We have this time. Well,
We do. Okay, so yeah. Yeah, that's a good point. Sorry, I'm not gonna do the operation. I am gonna show you some of the tougher examples of plugging in. I'm so sorry. Sorry, 1,000 times. But I just want to make sure we do some of the more complicated the evaluating ones. So we'll get to operations tomorrow. All right, so f of x, let's make this one. I know. Well, okay, I'll do one that's easy and one that's hard. Let's do negative x squared plus 2. And let's have g of x be, well, let's have g of x be nice. How about 3x? Just leave it at 3x. All right, so your instructions are going to be something like evaluate. So what if I asked you to evaluate something like g of 5y? What in the world are you going to do with that? Say it again.
15y.
Yeah, 15y. I'm still going to go to my g function. Whatever is inside the parentheses is what gets dumped in place of the variable. So in this case, I'm going to replace that x with a 5y. And then I just simplify from there. So it doesn't matter what's in there. It could be anything. I'm going to do 3, and then instead of times x, I'll be timesing 5y. So if I actually do that math out, you just get 15y. Does that make sense? So what's in there isn't always just going to be a single number. It could be anything. It could be an expression. It could be another variable. So let's try another one. Let's try g of, how about x plus 6?
please pardon the interruption. At this time, freshmen are headed back to their A block classes.
That was
Academic
fast.
Freshmen are headed back to their A block classes. Thank you.
Okay, what do we get? Nathan, go ahead. You got it. So again, I know I'm using the G function because it starts with a G. So I'm going to do, instead of doing 3 times X, I do 3 times everything that's in the parentheses. So I just dump it in place of the X plus 6. Since that's a binomial, right? It's got 2 terms. I need to distribute to both. So 3x plus 18 is my fully simplified answer. How's that? Okay-ish? All right, let's do one with the F function. How about, and here's where I'm probably going to trip some of you up, or maybe not, I don't know. Find me, let's just do F of -5. Try that. I'm so curious what you get out. Oh, you have the answer already? Hold on to it for 1 second. Let me give everybody a moment. Be careful with those negatives, my friends. All right, Zach, what do you get? Ooh. Did anybody else get -23? Good. It is the correct answer. If you did not get that, if you got 27, let me talk to you. The 27s. Let me show you the mistake you're making. All right, so I know I'm using the F function. So that negative that's in the original is still there, right? It doesn't just like disappear. So I'm going to bring it down. That negative is there. Now I need to replace just the X with whatever is inside that parentheses. Since it's a negative number, I'm going to put it in parentheses. So I have a -5 in there. And then I need to square that thing. And then I'm going to add 2 to it. So that is the correct way to substitute in that -5 into the original function that we had. Okay, so you should have parentheses around that thing because I'm going to be squaring a negative number. So we talked about that. You have to have the parentheses there. Now the question is, all right, well, I thought minus a negative just turned into a plus. So isn't it plus? And then I squared, I get 25 plus 2 is 27. Ah, but you forgot about dear Aunt Sally. Doesn't she say, please excuse my dear Aunt Sally, parentheses, exponents, multiply, divide, and subtract? Right? You with me? Okay. Parentheses. I do have a set of parentheses. There's nothing for me to do inside that parentheses. So there, that's done. The next thing I have to do is exponents. So before you can do this minus a negative business, you have to do the exponent first. So -5 squared, you're now looking at this. That negative is still there, but -5 squared is now a positive 25 plus 2. Oh, and that's where -25 plus 2 comes from. So yes, that final answer ends up being a -23. Oh, I can't tell you how many times kids mess that up. So yes, -23 final answer. There you have it. So again, if you are someone that got 27, I hope that makes more sense now. Okay, you got to be careful, careful, careful. And let me just give you one more and then I will let you do your homework. Let's try F of, how about 2x? Oh, sorry. Try that, F of 2x. How is that going to play out? So go back to that original F function and plug all that in and see what you get. Anybody got an answer? Zach, go ahead. I agree with you. So again, that original negative is going to stay. And now I'm going to replace that x with whatever is in my parentheses. So in this case, that's 2x. I'm going to square it and then I got to add 2 to it. Do you need those parentheses? Yeah, because if you don't, you're only gonna square the x and not the 2. You are squaring everything that x is. And in this case, x is all of this that's in the parentheses. So I gotta square all of it. Hello. And now I'm just evaluating. So 2x squared, that gets me the 4x squared. And I need to take this opposite. So negative 4x squared plus 2. And I can't go any further than that. How do we feel? I'll take that as a, we feel great. Yeah, you sure can. Okay, because we did not get to operations yet, we're just gonna do the front. So numbers 1 through 12, that's it.
They even got cookies. We didn't get cookies.
Wow.
Outrageous. Going with them when I was like, they couldn't have done it at the end of last year.
We would have had the field day
Well,
here.
too bad the remote didn't. Too bad, so sad. Oh, yeah, that was not even. That was like a 5-minute like.
That X disappeared and in its place. Yeah, so see how it's serving 3 times X? We got rid of that? Yeah. Same thing on this one. So instead of, where was the G? Okay, so instead of writing the correct way, we're doing 3 times whatever the
Because like the team that I was on, this ticket.
No, I got
Yeah.
Oh my goodness, do you remember that class? That was actually like such a good
I
class.
felt bad because I
Why?
was annoying. I was so I was just popping from down the whole time. And down.
No, what's in trouble? So just a front though.
Here's the guy that I was nonstop talking to, and just Stika thought I was mad.
Me and Elise read the book Baby Beluga. Oh wait, Blue Beluga. Oh wait, were you in that?
I was-
Okay, everybody, 1 through 12, we're gonna do all of them. So that's just the front side. Let me open it on Jupyter for you.
I just, so, you can say, solving kind of this.
Yeah, so you're going to take, do you know about function notation? You're gonna take the number in there, -10, and you put it in. Well, you put it in place of your variable. So whatever variable you have, you have to get rid of it. And now instead of writing 3 times X, I write 3 times.
At least it's easy.
Yeah, well, now you just solve it here, so it's -30.
I'll do it.
8.6. That's your answer. You don't touch anything on the right hand side. That's the. Literally, that's. You don't touch it. So G is not a variable.
Okay.
It's just the name of the function.
Oh, okay.
So you only handle the right hand side. Oh, so now we're gonna write 3 times, we don't write X, whatever is in the place. So you'll have 3 times -10.
Oh my God. Where's my?
All in your way.
No.
Yes, and then you just evaluate this.
Oh,
Does that make sense?